Okay, this is Ryan Zhang again from APAC Service Team. So this video is about agent security with OpenShell Part 2. In Part 2, I'm going to walk you through what we call Pattern 1 demos. This is the demo scenarios, all about the architecture of putting all the agents running inside OpenShell sandbox. So there's a separate one for pattern 2 in different videos. So let's walk this through. First, let's understand my demo environment. So I have 4 windows. First, let's have a look at this. Only 2 namespace get involved for this demo. This is my agents applications namespace. This is OpenShell control plane, the OpenShell gateway namespace. So let's have a look at what I have previously deployed for this. This one is ops agent without OpenShell. I'm going to compare this one with the ops agent running inside OpenShell sandbox environment. And the second one, we will not using it in this video. And the third one, Roast API, is internal API, which will facilitate our demo scenario. And then I have OpenShell dashboard. So this OpenShell dashboard will connect it to the OpenShell gateway. And as you can see, I already have my gateway config and also my Q1 large language model config as a provider, so it can be utilized by my sandbox pod. My agents will run inside sandbox pod. It will utilize the Q1 model through the provider. And okay, so far there's no sandbox running, and let me start my agent chat. I'm going to start 2 agent chat. In the above, I'm going to set my agent to this ops agent with OpenShell. So whenever I have a request, it's going to OpenShell gateway are going to create the ops agent with OpenShell part. And at the end, at the below, I'm going to start ops agent no OpenShell. So this agent, any input over here are going to routing through this part. So there's no OpenShell get involved. So we can compare the difference of the behavior. So let's first look at the very simple one. Show me the process. And I'm going to copy this same request over here. So that's running. So both will run. And as you can see, in the above windows, it's already showing the sandbox pod has been created. It's it's in the process, and in the below, because it's already have my ops agent running, and this is the ordinary container running without OpenShell. As you can see, this is just start a normal process in the container. Nothing special. But what is special is over here on the sandbox environment. You can see that my process So basically the logic of my ops agent is that once this ops agent receives the user's request, it will ask in the large language model what tool to be triggering. And then my agent will actually triggering the tool calling, and everything is running inside of OpenShell sandbox part. So now you can see the difference. As we explained previously, there will be a supervisor process, and this is my agent process. You can see it is running on different users. This is sandbox users. So that's why the sandbox environment can providing a different security layer, and also goes through the supervisors policies, etc. So with that said, this is my basic setup. Now you can see on my OpenShell dashboard, you can see this one. I can navigate to this sandbox part, and I can view the policies defined over here, some default policies being defined here, network policies, and the file system policies. And also I can see the logs if I want. So during the first request, you can see it have access the QN models through the inference local. This is configured on the OpenShift gateway as we described. There's no credential exposure to the agent. And okay, so that is the basic setup. Let's run the second scenario. Let's have a look. So OpenShift Sandbox will run your ops agent under Linux security mode, which means that it do not have privilege permissions of the ID, and it cannot run the sudo, and you cannot escalate the permissions. So make sure it's running safely. Let me show me the Linux ID, and maybe let me do this, trace a Linux command. Let's say date, a simple one. And let's do this test. So I'm going to run in both agents. Again, the above is using the sandbox part. In the below is the normal ops agent. So you can see it's already showing the Linux user as a root, because by intention, I put it on the running on root. And the date will also be shown, and the strace was running successfully, tracing this Linux command. Let's see in the sandbox scenario. As you can see, the user ID is a sandbox. It's not root. Again, this both this sandbox part and this ordinary part are running exactly the same image. So the logic totally are the same. The image have the root user ID as the user ID, but when you place it under OpenShell, it will forcefully start up in a constrained process. Okay, you can see it will do not allow this syscall. Okay, let's move on to the next scenario. The next scenario will be the look at the file system policies. What I'm going to do is show me etc password, and let me do more, append, let's say 4.4 eval host, etc host. Let me append this file, try to write to this file. And as a comparison, I will do it on this one as well. Let's see what is different. Now we can look at these logs files and the OpenShell dashboard. You can check on the logs, and later I will show you the policies. Now it's already returned. First, let's have a look at the permission denied. So the etc password do not allow. Let's have a look at the policies. So if you notice that in my file system policies, I have deliberately set up the read-only for this file system and rewrite for the a few of the folders. So etc password is not in the whitelist. So that is why it is denied. Usually in ordinary container, etc password is read-only. You can read that. And of course, etc host, it do not have no new privilege flag set. Of course, it do not allow the either sudo command or the root running to write this etc host file. So you can see that this was not be able to do it. But this file, you can see, is successfully has been done. Okay, so this is a comparison for that. So by running the agent on the OpenShell, you have file system policies to whitelist what you can read, what you can write. That's another layer protections. Let's have a look at the credential protections. As I mentioned earlier, this ops agent, if it's running under OpenShell, when it access the large language model, it have to go through the inference local, and all the credentials and the model keys was configured in the OpenShell gateway, which is running outside of the sandbox part. And let me exit this and show you lively. If I do this, copy this part, because this ops agent, it will be able to access the large language model for the nature of the agent's behavior. So if I doing this, you can see either you put in an environment variable or config file, the agent has a visibility to those model keys. And it's easy to understand, right? But let's look at this one, sandbox. If I want to connect to my sandbox part over here, I expect there's no such model key exposure. As I described, it will be dedicated to the OpenShell gateway. So that is also an important feature. So you don't want your agent access to the confidential credentials. And let's move on to scenario number 5. So I'm going to show you the network policies. Okay, what I'm going to do is download the block, and for some reason I need to ignore the SSL certificate validation. And let me copy internet URL for this case. I think I can make it bigger. Let's do this. And so far by default, I have a standard policies, which is over here. I expect it will deny because I do not config any Red Hat specific network policies. So let's check out. This is Arial. This is 403 forbidden. This is perfect. So the network policy has denied my request. You can see there's a one pending rules over here. So you can see also checking the logs. You can see this one has been denied by my network policies. This is an expected behavior of OpenShare sandbox. What I'm going to do is I'm going to whitelist this, whitelist internet, if I spell correctly. Okay, so now I'm going to do it again. So I can patch these policies without restart the path. With the same path, let's have a look the rules. We can monitor this. You can see when I go back to the rules, and the public whitelist has been there because I'm setting this policy during the runtime. It deliberately define that which binary can access this one. It's fine-grained control on that. And my true calling is occur, and as you can see, it's already been downloaded successfully. So it works. And that is another layer. Network policies, that's quite important. You can specify any binary tools have a specific network, the destination whitelist. Anything outside of the whitelist will be denied. That is a strong protection. Let's move to number 6 scenario. Okay, what OpenShare can do is not only blocking the HTTPs, the network, not only HTTP but also TCP, and not only the destination rules, but you can also understand the RESTful API. Let me show you. Who is writing down? You remember, I have a ROST API service over here. So when I send this request, my ops agent will be able to smart enough to figure out to finding the information from ROST API. And what we are going to show is that, let me have a look. So I need to set back the policies to standard policy, because in the internet policies, it get rid of my access to the ROST API. Let's monitor over here. Yeah, now you can see ROST API is over here. And it's deliberately defined allow only get head. Those are read-only method. And now you can see that it has a fetching my internal informations. And what about if I want to say update Brian Zhang's manager to Tom? So because my ROST API whitelist is only for read only, so this is going to be a write permissions. So it's going to update. I expect it will be denied. As you can see, it's been denied it here, and also you can monitor that it's been denied over here. So what you can do is policy equals to whitelist to rest. If I do this, so you can fine-grained control the behavior of your internal API access. So this is quite powerful, and you have a different level of control or your behavior of that. As you can see that it's already finished the job. Okay, with that said, let's move on to the last scenario, which is dual protections. So if I show you this, my agents are running as an ordinary pod, which is a runC as a container. In OpenShift, I can also do this, set a hard isolation using VM level of runtime. I can set the runtime equals to, I think it's kata. Yes, and I'm going to, yeah, you can see this will switch into kata, and this is doesn't make, I don't need that anymore. I just show you a array, show me the date, okay, or show me the uptime. I just start this kata container, and what I'm going to do is I'll show you some difference. First, let's verify that, and OC, let OC get pods. Let's see. Runtime. Not sure it's. Yeah, this one. So it's a RC, runC, and if I doing this, so this is a kata container, so runtime. So kata container is a VM, micro VM, serve as a container runtime. So if you are interested into the difference of kata container and runC container, what is the difference? And you can reference my previous video on that. So with that said, this is all about this running agent using OpenShell technology with pattern 1 architectures. Everything is running inside sandbox boundaries. So in next video, I'm going to walk you through some demos around the pattern 2. Thanks for watching.